A very good day, everyone. My name is Muhammad Haris bin Mahmud. I will proceed to the question A of the summarization of our findings on Lajak-Kuruih tablet B. So the data of 200 sample observation are taken at random from 3 production shifts and analyzed as below. From the set of data, pil Lajak-Kuruih B tablet, mean and standard deviation of weight, relative density and tensile strength had been calculated. Graph of 200 data sample for weight, relative density, and tensile strength also been plotted. So this is a table of sample size based on shift. For the morning shift, produce 73 tablets. For the evening shift, produce 66 tablets, and night shift produce 61 tablets. When accumulated, the grand total is 200 tablets produced. The next table is the average of weight, relative density, and tensile strength. So for the average weight, the morning shift has the highest average weight. For the average relative density, the highest is on evening shift. For the average tensile strength, the highest is evening shift. The next is a data dispersion based on weight, relative density, and tensile strength. So this is the data for the mean and standard deviation for the data dispersion. After calculating the mean and standard deviation of 200 tablets based on weight, relative density, and tensile strength, these are the data computed, and this is the graph that been plotted. The first graph is the weight graph. The second graph is the relative density graph. And the third one is the tensile strength graph. So, and the last one is the numerical data based on shift. So, in the morning, the sample size is 73, and this is the mean and standard deviation calculated on the morning shift. On the evening shift, the sample size is 66, and this is the mean and standard deviation calculated on the evening shift. And from the night shift, the sample size is 61, and this is the mean and standard deviation for the night shift. Okay, that's all from me for the answering part A. Next, my friend will continue.
Assalamualaikum and good morning. My name is Isaac bin Adim. I'm going to give an explanation on how I solve question B. Basically, this is the question given to us. And the first step is to select all the data. And we're going to click Insert and click Pivot Table and click OK. In this part, we're going to put the weight in both columns since the question only involves weight. For the right column, we're going to right click and choose Value Field Setting. And we're going to choose count. Count is the same as frequency. So for the left column, we're going to put it in group. From based on 300 is the lowest value and 400 is the maximum value. Then we can get the range of data. So we're going to continue to the next step is to make the hypothesis statement, which is this one. The 350 is mean value and 14 is standard deviation value. And the next part is this table. We're going to use the goodness of fit test, which OI is the frequency from the count. PI is the probability that we're going to use this formula, Z equals to X minus 350 divided by 14. EI is the value of N times by PI. N in this question will be 200. So for example, in this row, we will times 200 by 0.0021 and we will get 0.42. The next column is this one in blue color. The reason why we combine these three columns is because we observe the value of EI. It seems that the value is below than 5, So we have to combine it together, and we will get 12 for the new value of OI and 15.28 for the new value of EI. The next column is this formula. We're gonna find the value by using this formula for each range of data, and we're gonna total up the value. We will get 2.0113. The next part is to find the value of V. The value of V is 6 minus by 1, which is 5. And then we can get the value of x squared alpha V is 11.0705. In this case, the alpha is 0.05. Therefore, we can observe that the value of x squared test is smaller than the value of x squared alpha V. Therefore, the conclusion is failed to reject HO, and the weight of standard tablets follows the normal distribution of 350 milligram. That's all for my part. Thank you very much.
Today, I am Suindran. I'm here as representing my group for part C. As you can see, I have separated into question C into 3 parts: morning shift, evening shift, and night shift, as per the question asked. What I did was I separated all the data in Excel and calculated for all the 3 shifts, mean and standard deviation, and plot the graph. So by doing this, I am able to see the difference between them and able to analyze the data in much deeper or better way. So then after that, I used ANOVA single factor to obtain ANOVA's this graph, because by obtaining this table, I'll be able to decide, as the question requested, to accept or reject H0. Before I explain further, I'd like to tell the definition of H0 and H1. H0 is no significant difference between table weights from the different shifts. H1, significant difference between table weights from the different shifts. Okay, the summary table we obtain is from the 3 tables above, and in ANOVA tables, the 3 values that will determine the question's answer is SS, F, and P. And P value is the most important value. And as you can see, I've done a bit of calculation here to prove my theory. What I did was I obtained the P value, which is 0.6553, as you can see from the table. In this case, I also choose the level significant A, 0.05. Since the P value is much more bigger than 0.05 A value, we conclude that fail to reject H0, and there's no significant difference between table weights. Means, as the question asks, is there any significant difference between the 3 shifts? My answer is there's no change. It's all the same. No, there's no significant change. Okay. So to prove that, this is the conclusion over here, and that's all from my part.
Hi,
Thank
my
you,
name
everyone.
is Ki Hui Feng. I will continue the presentation for question D. First of all, the relative density and the tensile strength of the tablet can be used to determine the tablet hardness. Based on the studies, it showed that the relative density is independent variable, while the tensile strength is the dependent variable. A best fit line graph was plotted using the Microsoft Excel. For the regression statistic table, it showed that we are able to get the multiple R value, which indicate that linear relationship is getting stronger in the positive direction, since the value is close to the positive one. While the value of the R square indicates that about 70.7% of the data fits the regression model. Besides, you can see in the ANOVA table, we need to do the analysis test, and then we need to find the critical value and the decision rule. We will reject H if the F test is more than F critical. Since our F test is greater than F critical value, thus we have enough evidence to reject the H now. We can conclude that the linear regression is significantly exists between the tensile strength and the relative density at 0.05 level of significance. Moving to the prediction tensile strength, the equation of y equal to 0.0826x minus 0.1725, which is the fitted linear regression equation, which 0.0826 is the x variable and the negative 0.1725 is the intersection point of the graph. Then we need to substitute the x variable, which is the relative density, given into the equation to get the prediction for tensile strength. Then the tensile strength value for the prediction for each relative density for 68%, 74.3%, and 80.1%. As the value of the data deviate on the best fit line, we can conclude that the prediction of the data may not accurate. After all the observation, we can conclude that the regression model that we use to carry out for this prediction is valid. As for the ANOVA test, the linearity is significantly existing between the tensile strength and the relative density at 0.05 level of significance. Moreover, the normality of the tensile strength is also satisfied and the good fitted linear regression model is plotted. So that's all from us. Thank you.